I'll call this as an epsilon ball. Okay, so ball, okay, around the origin. Do you guys know all this? If you know, then I'll probably skip it. How many of you knew before? At least, okay. How many of you did not know? Huh? What about you? You knew, you didn't know, don't care. There's so many options. I cannot keep. Huh? You knew. Okay, so then you just let me know so that I can accelerate. Okay, so I'll just write because I need the notation. So an epsilon ball around the origin is defined as, okay, I'll call this as an epsilon open ball. Okay, so whenever I say epsilon ball, it's an open ball, right? As, how do I write this? I'll write this as, it's centered around the origin. I'll write it as 0. Distance is, or the radius is epsilon, which is all those points x in, I'll write it as Cn. Okay, so I'll deal with the general vector space Cn, such that distance from x to origin is x minus 0 norm, right? I'll look at 2 is less than or equal, oh, well, I have to look at open ball. That means all the boundary points should be left out, right? It should be less than epsilon. Do you agree with this? Right? Now, how do you define a ball around some point y? Let's say this is the picture, right? So this is your origin, and let's say this is your point y, and I want to write an epsilon ball around this. So what should I do? So this is how I write b of around y. I want to write an epsilon ball. It is all those x in Cn such that norm of x minus y is less than epsilon. Right? This is an open ball. How do you define a closed ball? You make less than or equal to, right? So you get a closed ball. Okay. Now I can change my norm, right? This is the 2 norm. That's what I've been considering, right? So it's a 2 norm. I can change my 2 norm to q norm, right? So what is a q norm? You remember, you looked at the inner product space with q, positive semi-definite matrix, and defined a q norm like this. Let's see what happens if you have a q norm, right? Let's see, suppose I replace 2 norm by q norm, right? What will happen? So for example, let's look at this, right? Epsilon is basically, it is all those vectors such that the q norm distance of x is less than epsilon. What is q norm distance? It's square root of x summation qx is less than epsilon, right? This is same as x belonging to Cn, such that I can square on both sides, right? Because both are positive, so I can square. Nothing changes. X summation qx is less than epsilon square. Can you geometrically explain how does it look like? For example, in 2 dimension. Q is symmetric, okay? So keep that in mind. Q is positive definite. If it is positive semi-definite, I mean, if it is 0, then there is nothing there, but it will be 0. It's a non-zero matrix. Okay. Now, can you describe how does it look like? Can somebody tell me? So, how does it look like? Okay, people online. At least you have a chance to Google it quickly and answer. I mean, if you bother to do so. Huh? Okay. Suppose I take Q to be identity, I'll get a circle, right? X1 squared plus X2 squared is less than or equal to epsilon squared. That's what you get. Q is identity, right? If you take some other Q, what will you get? Let's say I'll take half, 0, 0. What do I get? It's x1 squared by half by 2 plus x2 squared by 2 is less than epsilon squared. Okay, I can take for example 1 by 2, 1 by let's say 1 by 4. What do I get? X1 squared by 2 plus x2 squared by 4 is less than epsilon squared. What is that called? Ellipse, right? So in other words, I'm looking at all the points within an ellipse. So this is called an ellipsoid. Well, still I call it as a ball because the way I have defined ball is basically a set of all points is that x less than norm of x less than epsilon, right? So it's a ball with respect to that norm q. But if you're looking at the actual geometry, it will be as ellipsoid, right? It is something like this, right? So this is how it looks like. I don't know if I have written ellipsoid correctly, but it is all the points inside this ellipse, excluding the boundary points, right? So you can imagine the same thing in 3 dimension also, but beyond that we cannot, right? Is that fine? Okay. Okay. So now, so that means, it's not necessary that the moment you say an epsilon ball in n dimension, it depends on what kind of norm you have used to define the ball, right? By changing the norm, you'll get different shapes, right? So keep that in mind. Okay. In fact, I can take a vector and project onto norm. So what do you mean by that? So maybe let's look at that. Suppose I have a epsilon ball like this. Okay, this is an epsilon ball, right? And I have a vector. Okay, so let's say this is your vector. Okay, so I want to project this onto this ellipsoid. So what do you mean by projection? What do you mean by projection? Okay, I should find a point inside the ellipse such that the distance from that point to the vector should be as small as possible, right? Is that fine? So just to give you an idea, so I don't know, maybe have I written the ellipsoid correctly? Right. This is the point, right? I want to find a point inside the ellipse such that it is the closest point to this point. Suppose this vector is v and this vector is x. I want to ensure that x should be as close as possible to v, but with the constraint that x should be within an ellipse, right? So how do I write this? The problem would be, so I want to ensure that the distance between x and v, well, it depends on what distance you want to measure. You can use any norm. For example, typically we use 2 norms, right? I want to minimize this, right, for all x, but it's not any x, right? Well, then it is easy, right? So if it is any x, I'll take it x equal to v, right? Then you'll get 0, done, right? But I want this x to be ellipsoid, right? So how do I write this? Let's say q0 epsilon, right? That means all those points within an epsilon ellipsoid, right? bq0 comma epsilon. Maybe I'll change the notation here. I'll call this as bq epsilon because it depends on q, right? It's defined that way. So that means I'm going to look at all the points within the ellipsoid and compute the distance from that point to v. Okay, among all the points, I'm going to find the least, right? Well, this is an optimization problem. Suppose q is identity. What do you think is the solution? So you have a circle like this, and this is the center, and you have a point V. Now I want to find a point X inside the circle such that V is the closest. So which one do you think is the closest? Huh? Well, this point, right? But there is a problem, right? There is a technical problem. Of course, we engineers may not care about this, but still, can somebody recognize what is the technical problem here? The way I have posed this problem, right? If Q is identity or even otherwise, do you think there is an issue? Huh? Do you think the point can be inside the sphere, inside the ellipsoid? Never, right? I can move. There is some epsilon freedom around it, so I can move in some direction so that I'll be closer to that point, right? So it cannot be interior of your ellipsoid. What is the only possibility? Boundary, but boundary. What is the issue now? Tell me. Huh? So what should I do now? So that means, can I write minimize over all x? What should I do? It's a technical thing, right? So some name change I have to do. Huh? Te- Well, there is a convenient way of fixing this problem, right? By changing the name. Right? That's what I have to do. It's not guaranteed. Okay? Fine. So that means I'll take the infimum. Therefore, the problem is fixed. So now the projection. So this is also called projection. Okay. The same projection that we looked at earlier. In fact, we posed this as an optimization problem even there, and the solution turned out to be projection. Right. So this is also called projecting the point V onto the set BQ0, comma epsilon. Right? That's what it means. Okay, good. So one more notation. So can somebody guess what this means? This is just a notation. BQ of 0, comma epsilon. What is this? It's called the closure operation, meaning I'm going to push all the boundary points also, right? That means it's closure of the open set is the closed set. So this is a closed set. Is the closed set of all x such that this is x q norm is less than or equal to epsilon. Okay, not less than epsilon, it's less than or equal to epsilon. So that's all. Okay. Okay, so now we have learned some geometry, right, in n-dimensional space. So we know what norm is, what is distance, and so on, right? We can, and you know the sequence, and when I say the sequence converges, you know what it means, right? The distance norm should go to 0. Okay, so now let's look at one algorithm. Okay, so I'll ask you to figure out this algorithm. Okay, this has got nothing to do with your let's say data analysis, but it has got something to do with the linear algebra, or in fact in data analysis you will use these things, the eigenvalue decomposition. So inside your program or inside your function, this is how it gets implemented. So suppose let's say this is an example.